This is Chapter 6.1 lecture, part 1. In Chapter 6, we talk about probability again. This time, we're specifically going to talk about something called discrete random variables in the first section and discrete probability distributions. Sounds really complex, but the idea is this, if we want to read this part here. Consider a probability experiment in which we flip a coin 2 times. The outcomes of the experiment are heads, 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 tails, tails, heads, tails, tails. Rather than being interested in a particular outcome, like if we get a heads, heads, or tails, tails, what's the probability of those outcomes? We might be interested in the number of heads that we get when we flip 2 coins. If the outcome of a probability experiment is a numerical result, we say the outcome is a random variable. So what's the probability of getting 2 heads? What's the probability of getting 1 heads? You can see that would be 3 out of 4 in this case. Um, and the random variable, again, is a numerical measure of the outcome of a probability experiment. And again, where that outcome is we're interested in is related to a numerical result. So let's take a look. Um, take a look at what you would be putting here. So in our notes, the first thing that of interest here is going to be the first thing you put in there, a random variable. Okay, and so what's going to happen is a random variable is a numerical measure of the outcome of a probability experiment. A variable changes, so its value is determined by chance. Um, by chance, random variables are denoted using letters such as X. We use a big capital letter X. And so we have 2 different types of random variables. One of them is going to be what we call a discrete. And again, this is related to what we have talked about in the past. And the other one is going to be what we call a continuous random variable. So these terms are directly related to what we've had learned before. And so again, the terminology right now is a random variable. And so discrete random variables, as you take a look, can be plotted on a number line with spacing between each points. What's the probability that someone makes 3 free throws when they shoot the ball? Continuous, right? That would be discrete because you can only have 1, 2, 3. How many free throws someone makes? Continuous could be like a length of time. What's the probability that I spend 5.5 minutes on the phone with my parents or with my mother? And so when the variable can be continuous, and we're going to apply probabilities to that, then it's considered a continuous random variable. Let's take a look at the first examples that we have here. In these first examples that we have here, determine which ones are discrete and which one are random. Take a look, read that real quick. Okay, so you're considering the first situation. Think about it, discrete or continuous random variable. Determine the number of A's earned in a section of statistics with 15 students. So again, what's the probability that 10 students get an A? What's the probability that 3 students? So I'm asking a probability question with a numerical measure. And so the number of A's earned in the section, in this case, would be discrete, because you can't have 3.5 students. You can have 3.3 students. The number of cars that travel through McDonald's in the next hour, that would also be discrete. The speed of the next car that passes a state trooper, if they are using some very advanced technology, then I would say this is a continuous measure, continuous random variable. Next piece, identify another new term called probability distribution. So that's a new term here. Let's go ahead and take a look at that. And so fill it in on your notes there. The probability distribution And so what we're interested in is once we know what the random variable is, we want to know how, what are the probabilities of some event occurring, some numerical event occurring. And so we would use a probability distribution that looks like right here. It's a table of values. We've seen this before. We've talked about this being a probability model before. In this case, probability models are the general term. And it's going to follow the same rules that it needs to add up to 100%. And it needs to be a probability, which was a probability model before. So a probability distribution can be in the form of a table, a graph, and so it's important to acknowledge that right there here, just like all other distributions when we talked about it. It can be a table, a graph, or a mathematical formula we would use to describe those. And so in this case, here's a situation where a basketball player shooting 3 free throws, and the distribution, the probability that they're going to make 0 is 1%. To make 1 free throw out of the 3 is 10%, 2 out of the 3, 38, and 3 out of 3 is 51%. And so what does P3 mean? That means what's the probability of the shooter, what does that mean? It's 0.51, which means there's a 51% chance 51% chance the player makes 3 shots. That's what that. And what does P of X represent? P of X is the probability, right? It's the probability of making 0 to 3 shots, and that's what it represents. And so this is an example of a probability distribution for a random variable. See, these are numerical measurements here. This is very different than saying, what's the probability of someone having dinner ready for me at home? What's the probability that I meet a friend at the store? Those are not numerical values. And so we have that. There are some rules for a probability distribution, and they're going to follow the same idea that we've had before. And so fill these in here. Here is what you would be putting in. There's a random. Here are notes here from our PowerPoint that you could download. What are the rules? There are the rules right there. Rules for a discrete probability distribution. To note the probability, the random variable x equals x, then the sum of all the probabilities has to equal 1, which again, that 1 represents 100%. So you want to keep that in mind there. And then that the probability each of those values has to be between 0 and 1. And so you have that as our scenario there. Those are the rules, right? The first rule has to be that the sum of all of those probabilities, sorry, that's the sigma symbol, has to equal 1. And then the second rule is that each of those probabilities has to be 1. Again, this is very similar to a probability model that we had in the previous section. And we'll end this section with this example here, identifying discrete probability distributions. Which one is a discrete probability distribution? I can eliminate this one here. Since this is a negative value, I know this is not one. And then all of these have values between 0 and 1, so that meets condition 2. And then the other thing we need to realize is we add this up, which ones. So if I add this up, this is 10, 20, 40, 50, 80, 84, 86, 87. This only, if I add that up, it only equals 0.87. And so that would not be a probability distribution either. And then on this one over here, 10, 20, 40, 60, sorry, 40, 50, 80, 84, 86, 90. Am I short here? Let me count wrong again. 10, 20, 40, 50, 80, 94, 96. So when we add that up, that equals 1. So this one here is yes. This is a probability distribution. That's the end of part 1.